Hi everyone. As already mentioned, my name is Mike Merritt-Holmes. I'm CEO of Big Data Partnership. We're a consultancy that focuses on professional services around big data and training. What I want to talk about today is actually something that is a bit different to the kind of talks that you normally get. So there's quite a lot of big data shows that are around these days. There's quite a lot of vendors talking about how wonderful their products are. And there are also lots of companies talking about how to implement big data in your organization and the technical challenges around that. But what I really want to talk about is actually some of the business transformation sides of that. What I mean by business transformation is how do you get business or your organization as a whole to start thinking about how to adopt and use the big data technology that you're putting in place and really get value from it. And that's actually a challenge in itself, because there's a whole host of things which we'll cover in this. So basically, I'm first of all just going to talk a little bit about the big data hype cycle, if you like. And you've probably seen a lot of these quotes already from Gartner, McKinsey, talking about very large numbers, talking about how you're going to have a 20% competitive advantage over your other competitors and all that kind of stuff. Wonderful kind of big figures that you can be aiming at and thinking big data to be wonderful. We've also probably seen the sort of pioneers, if you like, talking about how many billions of petabytes they're processing through and getting insight in various different ways, and some success stories about how great it is. And I'm sure you've seen diagrams like this around, unstructured data, structured data. Just give us any data, we'll process it, we'll put it into our big data system, and we can analyze stuff and we can give you great insight. And you may have probably seen the 3 Vs, or heard about the 3 Vs, or heard about the 5 Vs, or the 7 Vs, or the 9 Vs, as lots of people like to talk about them. And actually, on that note, we did some analysis recently on over 100,000 digital documents that were focused around looking at the 3 Vs, actually. Well, the documents were looking at big data in general, but we focused around all these different Vs that everyone was talking about, and tried to look at actually what were people really talking about, what were the Vs that were coming up in these documents. And interestingly, the V that came up more than any other V in all these documents was actually value. Not velocity, not variety, not volume, but value. And I think value does sort of sit in the heart of this diagram when we're talking about big data, because you can talk about how quickly you can process stuff, but it really is about how you extract value from your data. But also, big data is about not just the technology, but it's about, you've got these wonderful open source tools now that some have been commercialized, some are still open source. You've got infrastructure as a service, such as Amazon, such as Google now. Rackspace is starting to offer similar products. You've got Microsoft with their HD Insights, making it very easy for entrepreneurs to start using the technology, for people without big budgets to start getting involved with big data. But you've also got a boom in data like Internet of Things, machine-to-machine logs, social media booms. You've got digitization of publications. So you've just got this information overload coming through over the internet or over logs. But from a personal point of view, you've also got this increased expectations from consumers that they want things presented to them in a more personal format. Either recommendations, or people like me also were buying these things. And that's something that consumers are now starting to expect from everyday experiences. So there's this kind of expectation and therefore desire from organizations to fulfill that expectation in terms of getting closer to their customers. And also there's these open data initiatives like the government, the US government, the UK government are putting in place, where they're saying, here's the data, here's all our public data, use it, look at it, turn them into products, turn them into new enterprise, and do something with it. So all these kind of things are really sort of bringing out what big data is about, this big data message. It's not just about technology. And there's also a mindset change. So businesses are starting to say, well, I've got all these logs in archives, but actually maybe there's some use in that. Maybe I can turn that into a new product. And Telefonica, for instance, is a good example of a company that's taken all this network logs and they've changed that into an actual asset, which they're now selling as a product, which I think is called Smart Steps. But this is what we really see as an organisation. We see, how do I invest in big data? Where do I invest? Do I have big data? Where do I start? What do I invest in? All these questions. Because companies are still trying to get their head around what it is. I've got all this technology, but I don't know where to start with it all. So let's take this question. We've got a CIO, for instance, who's saying, right, how do I implement big data in my organisation? And he's got IT that's telling him, well, you should use Hadoop, and we can put Hadoop in, and we'll put all this data in, and we're going to have this wonderful insight, etc. But he's a bit confused and a bit lost about what his strategy is. Now, when it comes to technical implementation, there are two schools of thought, or two ways that we really see companies implementing. The first is the way that we tend to recommend customers or organisations to go about it, and that's to kind of, first of all, educate and learn about where your strategic goals are, where your challenges are, and identify the use cases that fit a big data scenario, and start to work on some of those low-hanging fruit use cases so that you can do a proof of value and get people bought in, which is effectively our discover and develop phase. And then you've got this other school of thought, which is what we like to call build it and they will come. And it's organisations, they will spend a lot of money putting in a big data platform. They will sometimes spend a hell of a lot of money doing this, and they'll bring data from every place they could possibly find. They'll put it into this platform, and they'll start to think, right, now we've got this, and we've thought about how they might link together, we can start to get some real insight. But then they turn around to the business and they say, so we've got this great platform, what would you like? And the business tend to turn around and go, well, what can we have? And then you get this standoff where you've got the business and IT trying to find a solution to something they've built, or a problem to solve from something they've built, because they've built this great platform, but no one knows anything about it or what it's about. So this has its challenges, obviously. First of all, the business doesn't understand what big data is. So you can talk to the business and say, what would you like? But unless they understand the principles around big data, what you can do with the technology, how to think about data, how to think about the problem, you're never going to get the right opportunities to solve. You're never going to get your marketing department thinking about sentiment analysis and drawing that and using that to then push on and change the way they market if they don't understand about what's possible. You're not going to get someone thinking about predicting fraud before it's happened because they don't understand about machine learning, for instance. So you need to educate. Often what we find is businesses tend to look at big data or the word big data and associate it with BI and traditional BI tools that your data warehouse. And so when you ask what do you want from big data, they'll say, well, it'd be great if we could see the number of customers or number of sales based on these regions or by region, we can break it down and slice it down. That's great, but you can do that from your data warehouse. And Donald Rumsfeld is quite inspirational in this point, because your known unknowns are where your BI world is. They're the things that you want to find out, but you know what the question is, you know what to ask, you don't know it yet, but you know how to go and get it. The unknown unknowns are really where big data sits in terms of getting insight out, because you want to explore that data and find the insight, but you don't know where that might be yet. You don't know your data. You've got to really understand it. So the unknown unknowns are where big data really lies. But how do you build a business case for unknown unknowns? So you go off and you say, right, we want to do this really good project. We think we can predict fraud before much earlier than we normally could. And they go, great. So how are you going to do that? And I say, well, we can look at the data. We don't quite know what we're looking for yet. Okay, brilliant. And what do you expect to get out of it? Well, we think it'd be good, but we're not really sure what the ROI is because we don't know what we're looking for yet. How do you build a business case that someone's going to sign off around that? And really the only way to do that is to educate that decision maker about what big data is about the possibilities, about the process, and also change their mindset. So their mindset is very much around traditional ways of building things, and this is a very different way. Also, you need to make sure you've got that low-hanging fruit that you can take to them, because that first step towards your big data journey is actually about finding a really good example to showcase and say, right, this is why it's valuable, this is how we can prove it. And then getting them signed up to that, proving that and moving on. But it's also about this, which I've got no idea what that means, by the way, but it's actually about maths and about modeling and about statistical modeling. Basically, to get real insight, and I'm not talking about using big data for ETL, because you can use big data to improve ETL efficiencies, and that can be completely technology driven and can improve a process that already exists. I'm talking about where you are adding value through insight that you're getting from being able to join and look at data you couldn't previously look at before because it was unstructured or because it was in a format that was meant that the processing effort would be too expensive. But by using mathematics, you can start to unlock a lot of insight. By using things like machine learning and predictive modeling, you can really start to invent new products and all kinds. But to do that, you need this data scientist role, this role which you hear around, and who's going to discover that insight? Well, it's this data scientist. Who's going to find the right questions to ask? It's the data scientist. Who's going to visualize that data? Well, it could be a number of people, but that data scientist might be it. But where does the data scientist sit in the organization? I mean, do you have them in your workplace now? Do you think you have a data scientist? Do you need one? When do you need one? And where do you place them? Do you put them in IT or do you put them close to business? And if I was going to get a data scientist, well, how would I get one? So if you compare business intelligence to big data, you see that as your typical BI analyst will be looking at warehouses, they'll be cutting through data by different dimensions, doing analytics in a very structured manner. They'll be producing reports for people based on this, and everything's quite structured in their approach. With a data scientist, you're actually talking about someone who typically comes from a very statistical, mathematical background, has a lot of knowledge on different algorithms and techniques to use to get insight from data, and actually has a very hacking nature, if you like. So they're comfortable with technology, comfortable with taking data and turning it into a different form and combining stuff and munging through that data and really exploring the data in a form that it didn't start in to get the insight. And it's kind of those combinations that start to delve into what a data scientist is all about. It's about being able to be flexible with the data and explore it in a way that you wouldn't normally do in a traditional sense. So I'm not going to go through all this, but these are the sort of things that a data scientist would do. So they would munge through data, I always like that word, and understand data relationships, tell sort of stories from the data, mine through it, explore the data, split it, combine it, move it around, and really just mess around with the data to get the insight that they're looking for. And they'll use tools like this, and your average data scientist will use a number of these tools, but they won't necessarily have experience in every single one. But they'll use things like Weka and RapidMiner and tools such as the big data tools like Flume and Pig and Hive to manipulate their data into forms that they can then use to put into tools like R and put statistical models around. So they'll have all these different tool sets that they need to be able to get that insight. So if you go back to before and I said, well, you've got this build it and they will come, you've built a platform without actually knowing what you're trying to achieve yet. So you end up with the wrong tool set to achieve it. That often happens. You end up with a big Hadoop platform, but you don't have R in place, you don't have a way of moving things from R. You might have Pig and Hive because you've got Hadoop, but or a distribution of Hadoop. But effectively, you end up with the wrong type of tool sets to get maximum value. So if we go back to that initial question from our CIO, how do I implement big data in my organization? So IT obviously has got a view on that about what the technologies need to be, but we've kind of got like a five-step plan, if you like, that if you follow, you're going to be going down a much better road. So first of all, you need to educate. So I can't sort of stress this enough. Educating business from the bottom to the top, right to the very top, is really important. If you get that education, you'll get the buy-in to put the right people in the right places and to use the right tools. You'll also get a mind shift, which means that people will start to understand what the possibilities are and come up with ideas and ways in which they can utilize the technology to either increase revenue, increase the number of products you have, reduce cost. Your marketeers will start to come up with ideas. Wherever in your organization it is, will have ideas about how they can utilize. It could be your ad guys are putting ads on a website, for instance. Then once you've done that, you can start to understand the low-hanging fruit, as I said before. So pick some really easy use cases that are quite cheap to move and prove, and then get a business case written with your newly educated decision maker, and get that going. And then step 2 is actually your big data implementation, or your first one, which is about proving the technology, proving the value through a small use case. Of course, you've now got, by doing step 2, you then have a big data platform that's maybe smaller than the build it and they will come, but it has everything you need to deliver on that use case. And you can build from that. You can, one of the fundamental sort of properties of a big data solution is it's horizontally scalable, which means you can just add nodes, you can build out the scalability factor. It's not an issue. You don't have to plan that up front. And based on this, you can get buy-in from IT, and you get buy-in from the business. Then you need to recruit the right skills. So think about which engineers do I need, which data scientists do I need? Do I need a data scientist for my particular use case? You may well not do if it's just ETL. But once you've got those, where do they sit? Think about where they sit in your organization. It may be that because you're quite heavy as an analysis, maybe you're a LexisNexis or a Reed, and you have lots and lots of people doing lots of different types of analytics. Perhaps you want to set up a specialist NLP team that's going to be going through unstructured data and pulling out sentiment and segments of information and clustering across documents. Or perhaps you want to put your team or your data scientists very close to different parts of the business. So your first use case may be for the marketing departments, and maybe you have them working directly there, and they start to build a relationship and understanding of the things that are important. And then you allow your scientists to explore the data. So whilst IT may have set the platform up and they're managing that platform and they're providing the tool sets and the data, you need to be able to provide the data in the right format. So the data scientist may go to IT and say, actually, the problem I'm looking at, I could do with X, Y, and Z data, but we don't want a situation where the IT is going to say, well, here it is, you can access it over here, but don't mess around with it. Don't chop it up. Don't touch it. You don't want a data warehouse where you can just do reports. A data scientist will want to get their hands all over that and be messing around with it to get to where it needs to get to. So you need to make sure that your infrastructure supports that kind of moving around of data and being able to put data into one place where someone can mess around with it and get the insight. And of course, once you do that, you're giving your data scientists the opportunity to do machine learning and all kinds of clever algorithms. And once they do that, you can then take that back to IT and say, we've proved the value, and actually this is the model that really works for us. You need to build this and productionize it. So then IT can then work with the data scientists, or developers and engineers can work with the data scientists to put that into a more production state. But of course, once you've done that and you've unlocked the value, you've proven the value, you can then move on to a use case, and everyone's even more bought in, and it's easier to get that business case because you're already proving why the platform is so important. So in essence, if you want to hit the big numbers and we want to be really achieving these numbers, we need to think about not just the technology, but how we enable that technology in the way that we educate the business. And if we do that, we'll get those numbers. Thanks a lot.